Now we are moving into a calculation that relates to the time value of money that can be challenging for some students. Now if you are familiar with exponents and logarithms, then you should have no problem. But after watching this video, if you're still having trouble, then you'll probably need to attend one of the on-campus work sessions for this course prior to taking the test. Now what does the last line say in example 4.3? That's on page 95. How many years must Denise faithfully put away her money to succeed at becoming a millionaire? We know we will be solving for N. What does the rest of the problem say? Denise has her heart set on being a millionaire. She decides that at the end of every year she will put away $5,000 into her I Want to Be a Millionaire account. And we will make that number negative when we use the calculator. She expects to earn 6% annually. How many years must Denise faithfully put away money to succeed at becoming a millionaire? Okay, so let's look at the timeline. This will be, we'll just put it up here. Short timeline. Present value, future value. Because we are solving for N, we have no idea what N is. So we'll just write N equals X above the horizontal line, and under the line we will write 6%. Now we have identified all the problem, all the information we have been given in the problem, and we can see what is going on. For this video, we will solve this problem in the following two ways. One, we're going to use a formula and natural logs, and two, the financial calculator. Now, I'm getting ready to show you two formulas, and these are exactly the same thing, even though they look substantially different. Now, the base formula for this is payment times 1 plus R raised to the nth minus 1 divided by R. Now, we can convert this problem so that we are solving for N. Now, I'm not going to do a long step-by-step process of how to convert this N over using logarithms, but ultimately what you end up with is N is equal to the natural log of, I think it's kind of, I don't know if I left myself enough space here, future value times the rate divided by the payment plus 1. And then that is divided by the natural log of 1 plus R. Okay, let me put a little border around this. This is the formula. It's a little tight in here. Okay. This is the formula that we're working with. So when we apply, I need to put up here 1 million. When we apply the information that we have in this formula, what we end up with is N is equal to the natural log of 1 million times 0.06 divided by the payment, which is 5,000, plus 1. And then all of that is divided by the natural log 1.06. Okay. Now when we put this through the calculator, it's a very step-by-step process, okay? We're going to take the 60,000, okay, because we're going to multiply these together. So this is the logarithm of 60,000 divided by 5,000, which we got from right there, plus 1, divided by the logarithm of 1.06. We're going to get a little squished over here, so I'm going to go over here to this right side. Okay, so 60,000. We'll do this on the calculator. 60,000 divided by 5,000 equals 12. Okay, so that means we're going to put natural log of 12, okay, which is the result of this, plus 1, divided by the natural log of 1.06, okay. And of course, that's going to give us the natural log of 13, 12 plus 1, divided by the natural log of 1.06. And ultimately what we end up with is when we take the natural log of 13, and we're just going to 13 and push this LN button, okay? We end up with 2.564949 divided by the natural log of 1.06. 1.06 hit this LN button, which is going to give us 0.058269. And when we calculate that out, 2.564949 divided by 0.058269, we end up with 44.019101, which closely matches the book on page 96. Okay. Now, let's solve this same equation with the time value keys on the BA2 Plus. Now we know our N is equal to X. Our payment is going to be a negative 5,000. I over Y is 6. Our future value is 1 million. Okay, so let's go ahead and put all that in. So N, we don't know what N is. I over Y is 6. We have 0 present value. We're putting in our payment negative, and we know we want to have $1 million here. So that's going to be our future value, and then we're going to compute in. And when we compute in, we get 44.019177, which is very, very close to what we calculated above. Now you will notice that whenever you use more than one method, you might end up with a slightly different answer that when rounded properly matches. So you'll have to evaluate your answers carefully to make sure that they match.